Hello everyone, my name is Sudha Subramanian and I'm with Gandham. Today we would like to share our journey around some of the work we have done in pipeline templatization, release management and orchestration, cost optimizations for the cloud, and also share a little bit of our future mid to long-term plans with Spinnaker. We are hoping that you will get some tidbits, useful information, ideas, especially if you're starting out new. And thanks for joining our session today. Spinnaker has evolved a lot in the last 2 years since we embarked on our cloud journey. I'm a part of a team in Salesforce that runs and manages this platform for 20,000 plus engineers that use it on an everyday basis to deploy their application across multiple different clouds. We have dedicated teams focused on different aspects of the platform, and my team is primarily responsible for the user experience, starting from onboarding to the platform, pipeline, templatization and composition work, release management and orchestration. We also do cost optimizations for the cloud. There is also a talk from an architect, Edgar Magana, for the service team. He's talking on Spinnaker, so please do listen to his session if you get an opportunity. So I would like to start by giving some context around the landscape we operate in, because it is different in some ways. Some of our problems may be unique to us because of our scale and complexity of our requirements. However, I still feel there are a large set of problems that can be applicable to any enterprise scale company that is using Spinnaker. First and foremost, our environments and our services are defined in what we call as a bill of material manifest file. Environments to us is a logical grouping within which a service operates, and they are differentiated by the capabilities, their limitations, the level of support, and also the access control that you get for these different environments. Pretty much everything that we do, including pipeline creation to hydration, happens through this BOM file. The second biggest differentiator is the number of personas that uses Spinnaker. Engineers, they develop code, and they test it in an R&D environment. Apart from that, we have release teams for different business units that are primarily responsible for managing and releasing changes to production. We have site reliability engineers, service engineers that get called to handle emergency responses. Now, these teams require a cross-application or a cross-service view across different environments, unlike the application-specific view that Spinnaker offers today. So are our business owners who are interested in the state of world for the entire business. We have build teams that are responsible for building environments. Now, each of these different personas, they use Spinnaker differently for different needs. And we need to cater to all their requirements and needs. This leads us to our next big differentiator, which is our release workflow. They are complex. Services have multiple different components with slightly different requirements for ordering and sequencing. Some services have mutual exclusion constraints with other services, meaning we need to provide some kind of a locking constraints in our workflow. There are some services that need to be deployed on specific days of the week, which means we need to support long-running workflows. We also want to provide a way where releases are gradually done across these environments in order to reduce the blast radius and failure rates. Our next biggest differentiator is our scale. We have close to 2,000 applications, more than 70,000 pipelines, and we're doing over 2 million executions in a month, and we're just beginning. We have pipelines that does various different things like deploying applications, destroying services, creating resources like Kubernetes clusters, destroying resources, utility pipelines for one-off maintenance job, like if you want to create or seed your database. But the best part is for some of these use cases, we have been able to successfully extend Spinnaker or provide use cases around it, with Spinnaker still being the heart of everything that we do. With that context, I would like to talk a little bit about a journey through pipeline templating. When we started 2 years ago, there was no native pipeline templating support. MPTV2 was just starting or was in nascent stages, so we rolled out our own templating processor, which runs as a pipeline in Spinnaker, and it creates other pipelines from templates that are delivered to S3 buckets. We use Jinja as our templating language. And over a period of time, when our environment started growing, so are our developers. For every service that we add today, we create about 3 or 4 pipelines per region. And these pipelines are different pipeline types. We have a pipeline type for deploying, we have a type for destroying services in ASG groups, we have a type for creating resources or destroying resources. We have a baking type pipeline for creating VMs for EC2 workloads. We also have utility pipeline for maintenance jobs. We needed a way to somehow manage all these templates and make changes to them. So we came up with a library of stages which are versioned. Our pipelines are composed using the stage library. So that way it is easy for us to force a change to the template by changing the library. So not only templates, even pipelines in Spinnaker are versioned using labels that are mapped to a custom commit shop. We generate the custom commit shop by taking a snapshot of the entire pipeline hierarchy. By default, pipelines are created with the latest label, but engineers can always add more as they see the need. So did it work? It did, but there are some challenges with templating. Any new tooling that we add or introduce to developers tool set, it is going to slow adoption. And Jinja is definitely not fun to learn. In spite of all the great versioning and library mechanism that we developed over templates, it is still difficult for us to push changes because some of our developers have really customized their templates and use the power of Jinja, making it very hard for us to upgrade their templates. The second biggest challenge is with the processor, which runs as a Spinnaker pipeline, and it uses the Spinnaker API to create these templates sequentially. It adds a lot of scale and latency issues. So we're moving away from that model and making this processor a separate micro service of its own. We're also adding bulk API support to create templates in order to address our scale needs. So where we want to get to is we want to provide a higher level of abstraction for 80% of the use cases and expose templating only for powered users. We also want to get to a service manifest-based definition, which is based off on a common set of archetypes that we need to support for our use cases in Salesforce. With that, I would like to talk about our journey through the release workflow. It is very similar to our pipeline templating journey. At the beginning, we only had a single environment. So users were either using Spinnaker UI to trigger the deployments manually, or deployments were triggered on delivery of artifacts like Helm charts and Docker images. But as our environments started growing and spanning multiple regions, triggering through UI was not an option anymore. We also wanted to progressively deploy across these various different environments in order to ensure a safe rollout. This is where I would like to distinguish between a release and a deploy. A release could be related to any kind of change, not necessarily deployment. It could be creating a resource, or it could be some maintenance job that you do across these environments. And there are several orthogonal aspects around a release, like promotion criteria across these environments, service interdependencies, long-running workflows, schedule releases in order to, say, patch your VMs. That release requires its own distinction. So in order for us to be able to gradually release a change across these different environments, we created what we call as a wrapper or a master pipeline that aggregated unit pipelines across these different environments, starting with dev, then stage, test stage, and production. The pipeline was triggered using a manifest file that developers would create and check into Git, which would then be made available in an S3 bucket. The manifest file contained the artifact and pipeline parameter and other parameter overrides across for the different regions, while the master pipeline defined the how or the route the release workflow will take. The manifest file for us defined the what. Did it work? It did, but there are some challenges. Master pipeline or the wrapper pipeline is very static in nature, and services wanted a different way to orchestrate their releases. Some services wanted to do a percentage-based rollout. Some services wanted their release flow to be to start on a external event. And some of these constructs are very difficult to express through pipelines. Also, the UI was cumbersome with such huge pipeline graphs. It both in terms of user experience, also in terms of performance, it was not good. So where we want to get to is we want to go with a release. We want to provide a release manifest-based definition that will not create these master pipelines, but would dynamically orchestrate the unit pipelines based on a manifest file. So users will be able to create multiple such release workflow templates for different use cases. And such an orchestration service will also provide an ability for users to create dynamic release flows. And it will also make it easy for us to add these complex use cases to the service, which we cannot do it through a pipeline. So this is by no means a complete list. We are making several OSS contributions across our different teams in our org, and we'll continue to do so in the future as well, working closely with the community. And with that, I would like to turn it over to Vamshi to talk about the cost optimization work that we are doing. Thank you.
Thank you, Sudha, and good afternoon, everybody. My name is Vamshi, and I work in the Spinnaker group here at Salesforce, working on a couple of different aspects related to increasing cost awareness and some of the roadmap items related to cost optimization. So in this next couple of slides, I'll be taking you through providing an overview of how we do the cost awareness and cost optimization here at Salesforce on public substrates, and look into those aspects a bit more detail with some of the code walkthrough. So cost optimization, as we all know, is one of the 5 key pillars of AWS well-architected framework that includes operational excellence, security, reliability, and performance efficiency. So we will discuss some overview of the tools, techniques, and best practices that can help us to accomplish these things. So kind of like looking at a very high level, some of the design principles that help us to kind of like frame our aspects around cost optimization include investing into a cloud financial management, particularly around making conscious decisions to invest into resources and time that will enable us to accomplish these outcomes. And in addition to that, also kind of like adopting a specific consumption model that could help with paying for resources that you consume versus eliminating the waste in terms of the resources that you may not be using or you may not be using them efficiently. So that also involves aspect of measuring your return of investment versus gains from increasing your output, functionality, reducing cost in terms of having an effective overall efficiency. And the other aspect that kind of like also helps us in this area is kind of like focusing on business projects by leveraging the heavy lifting that's done by AWS for the data center operations versus stop spending on money that is undifferentiated heavy lifting costs. This also includes aspects around identifying your costs for individual services that you might be consuming on a public substrate, and attributing those costs and workload usage to individual service owners within your organization to help them measure and also champion the aspects around cost optimization. So with that, if we kind of like now distill down a bit more deeper into the next level, this brings us aspects around what are some of those best practices that we could kind of like adapt, engage, and evolve out of those. So particularly around cloud financial management, there are aspects around establishing, as I mentioned, a specific function or a team that is focused on building the tooling, automation, and increasing awareness aspects around that. So that's a key important fundamental step. And also, this also includes partnering closely with your finance team. The technology teams and finance teams need to collaborate closely to kind of like establish all the different aspects around budgeting, forecasting, and aspects related to capacity management. So that would also kind of like bring in aspects related to bringing in cost-aware processes and integrations. Say, for example, your change management process, or say your monitoring end-to-end service could also be an additional added lens to bring in some additional visibility to these aspects around the cost. And last but not the least, there is also an element of cultural transformation wherein the service owners, the individual Scrum teams are also equally responsible for kind of like driving this particular thing by championing the cost optimization. So the next element that's kind of like more involved is more around the cost-effective resources. So this could be either looking into aspects related to selecting the correct resource type or a size or the number of resources. So that also involves, again, at a broader level, high level, selecting the best pricing model among all the different pricing models that a cloud provider might be providing you. And the other interesting aspect in terms of this is more around the data transformation. So there are, again, aspects you could look into modeling the data transfer and how to kind of like understand those costs and optimize the costs that are incurred purely because of data transfers. So the third aspect that's kind of like more around demand and supply. So this involves aspects related to kind of like building in tools that will help you to analyze the workload analysis, its efficiency, demand management, and also aspects related to demand based on supply. Like what I mean by that is more along the lines of efficiently utilizing the elasticity of the cloud by optimizing your parameters around each of the individual services. So there is also another element based on the time-based supply. So for example, you have lower environments that are like dev or test that may not be required to run 24/7. Again, that's a case-to-case basis thing that varies based on a service. There may be use cases where you need that 24/7 versus there may be use cases where you may not need that. So those are probably elements to see how you could automatically schedule them to turn off when they're not required. And on the optimization end, so that's again, and it's not a one-time thing, it's a continuous journey. And to that end, it's important to also develop a review process and use that review process as a guideline to identify opportunities and implement the changes to the services to continuously optimize your services to see how it can help you to reduce costs. And last but not the least, this is more around the aspect of expenditure and usage awareness that includes governance with making some policies, as well as being able to look into areas around building guardrails. And to that end, tagging, which is something that we'll discuss in the next couple of slides, is more around bringing in this awareness of the cost and utilization of the various different resources, and how tagging the resources can help you accomplish that. So let's take a look into that a little bit more deeper. So in terms of tagging, there could be, again, depending on your organization needs, there could be various different use cases. Beyond cost attribution, it could be also aspects related to context awareness, ownership attribution, and so on and so forth. Particularly at Salesforce, if we have to kind of like broadly categorize the various different workflows for cost attribution in terms of the various different types of workloads, it could boil down to three different major provisioning channels. One is the native cloud provider within Spinnaker that has the capabilities to spin up resources. And then again, integrations with your Terraform module to have Terraform manage your Terraform manifest to manage your resource provisioning. And third is deployment of resources using something like Helm to deploy your services within a Kubernetes cluster. So in this picture, what we can see here is like the users are empowered to either utilize any of these three channels, and we have something called as OPA, Open Policy Agent. Again, that's an open source library, which I'll get to its details in a minute, which is kind of like the main controller to build your guardrails around what a developer could do or could not do in terms of meeting certain policies about the governance aspect we discussed a few minutes ago. So all these different integrations of OPA Policy Agent, either before hitting Spinnaker runtime or during Spinnaker runtime, at the time of build or at the time of deploy, could be performing various different types of checks that you may want to either provide a feedback to the developer way earlier in the build cycle versus the final validations you may want to do right before the deploy. So a policy owner is the one that could be kind of like implementing or creating these policies to ship them to the relevant components. And in terms of tagging, you may have an external persistent store that you might be looking at in terms of being the source of truth or the system of record to inherit the tag key values with regards to the injection. So we've built integrations for all these various three different workflows in Spinnaker using the Jinja 2 to inherit and apply the relevant tag key values to all the various different resources that are being provisioned. Either in terms of the Terraform plan and apply stage, or through the Spinnaker native cloud provider by integrating the stacks with the relevant Jinja macros, or using the Helm bake stage. Helm bake stage is a type of stage, again, in Spinnaker that can help you override certain metadata in your Helm charts, and you can inject the labels for your service deployments into a KH cluster. So that kind of like, again, provides the unified view of ensuring that the policies are kind of like giving that feedback to the end users. And here is an example of a open policy agent policy code that's trying to validate whether the presence of labels is indeed there for the deployment type charts versus returning the relevant error code back to the user in terms of what might be missing there, so that the developer can take immediate action to make sure that those cost attribution tags or labels are injected. So again, Open Policy Agent is an open source general purpose policy engine that unifies policy enforcement across the stack. And it provides a high-level declarative language that lets you specify policy as code with simple APIs to offload the policy-making decisions from your workflows. So with that in mind, looking into the set of accomplishments, what we have done so far, we were able to attribute metrics for 98% of the resource types. And we have about 99.8% of the cost attribution to compute resource types, various different compute resource types. And we have a coverage of about 200 plus different service types that includes compute, storage, networking, so on and so forth. And on the guardrails and leveraging OPA, this is again a cumulative number so far in the last few months. We have about 400K plus OPA validations and executions that have helped us to make sure we are meeting the internal governance guidelines. So on the roadmap perspective, we hope to kind of like, again, look ahead in terms of addressing some of the indirect cost attributions, mainly particularly around shared services, to kind of like go into that area. And in addition to that, we also are currently working on adding a service that can retroactively apply tags for resources that may or may not have had accurate tags, or more in terms of some of the use cases that cannot be handled at the time of deploy to apply these tags. And last but not the least, we are also looking ways to kind of like having some integrations built into the provisioning pipelines and Spinnaker pipelines to do the left shift in terms of the cost optimization, so that there is a direct feedback right before the deployment is done. So with that in mind, thank you all for your time today. I hope you enjoyed the conference. And last but not the least, we are hiring. And if you're interested, please feel free to reach out to me or Sudha. Thank you very much.